In this video, we are going to discuss the valuation of currency swaps using a problem similar to a problem out of the excellent text Options, Futures, and Derivatives by John Hall. Suppose that the term structure of interest rates is flat in the United States and in Europe. The dollar interest rate is currently 5% per annum, and the European interest rate is 4% per annum. We will re-put this data down here, 5% and 4% for the dollar and euro interest rates. The current exchange rate is $0.9 per euro. Under the terms of the swap agreement, a financial institution pays 0.5% per annum in euros and receives 1% per annum in dollars. 0.5% per annum in euros, 1% in dollars. The principals of the two currencies are $12 million and 10 million euros. $12 million, 10 million euros. Payments are exchanged every year, with one exchange having just taken place. The swap will last 2 more years. What is the value of the swap to the financial institution? Assume all interest rates are continuously compounded. So payments are exchanged every year. One exchange just took place, so there will be one payment 1 year from now and the final payment 2 years from now. We will value this swap in 2 different ways, the forward rate agreement method and the difference in bond values method. We will start with the forward rate agreement method. To do this, the first thing we have to do is get an estimate of the exchange rate 1 year from now and 2 years from now. Currently it's $0.9 per euro. 1 year from now, we'll use this formula right here. Forward rates are going to be spot rates times the exponent. Since it's dollars per euro, we need dollars on top, euros on bottom. So it'll be R dollars minus R euros taken to the nth power for the number of years. Or you can also write this as spot rate exponent R dollars times N over exponent R euros times N. Doing this mathematically, we have $0.9 per euro times the exponent in 1 year of 5% in dollars divided by 4% in euros gives us the 1 year forward rate of $0.91 per euro. For 2 years, it's going to be 0.9 times exponent of 5% times 2 divided by exponent of 4% times 2, and that's going to give us $0.92 per euro. So to do the difference in payments method, we will next need to figure out what is the payment 1 year from now and what is the payment 2 years from now. Well, the payment in dollars is going to be 0.01 times 12, the swap dollar rate, times the principal in dollars of 12 million. So that's going to give us $0.12 million. And then the payment in euros 1 year from now is going to be 0.5% times 10 million. And that's going to give us 0.05 million euros. Write that out here, 0.005 times 10 gives us 0.05 million euros. So those are the payments 1 year from now. The payments 2 years from now, well, we'll have the return of principal of 1 times the interest rate in dollars of 1%, 1.01 times 12 million. 1.01 times 12 million gives us $12.12 million. And then the payment 2 years from now in euros is going to be the return of principal of 1 times the 0.5%, 0.005 times 10 million. It's going to give us right here 1.005 times 10 million, 10.05 million euros payment in 2 years. So under the difference of payments method, the payment in 1 year here is going to be $0.12 million minus 0.05, so $0.12 million minus 0.05 million euros times the exchange rate in 1 year of $0.91 per euro. Over here, this gives us C20 minus G20 times, up here, I13 gives us roughly $0.07 million. It's rounded here it's more exact, $0.075 million. So that is the difference of payments value in 1 year in dollars. In 2 years in dollars, we will have $12.12 million minus $10.05 million times the exchange rate in 2 years of 0.92, and that will give us $2.89 million. Again, C21, which is right here, minus G21 times the exchange rate L13, which is over here at 0.12, gives us $2.89 million. So the value of the swap using the forward rate agreement would be the value here in 1 year, more exactly that's $0.075 million, present value thereof, discounted at 5% in 1 year, plus the value in 2 years, 2.892, present value thereof for 2 years, exponent of 0.05 squared, gives us the present value using the value of the swaps of forward rate agreements, $2.69 million. So that's one way of valuing the swap. The other way would be the difference in bond values method. The difference in bond values method, well, we still use the same cash flows, but we first find the value of a dollar bond, then the value of a euro bond, and then we subtract one from the other. So the value of the dollar bond is going to be the payment of $0.12 million discounted in 1 year at 5%, and then the next payment of $12.12 million discounted in year 2 at 5%. Shown here, we have C20 and C21 as the payments, these two. Exponent of C8, that's the interest rate in dollars for 1 year, and C8 for 2 years. And we get the value of the dollar bond today is $11.08 million. Then we do the same thing for euros. The value of the euro bond today is going to be 0.05, right here payment, discounted for 1 year at 4%, the euro interest rate, and then 10.05, discounted at the euro interest rate of 4% for 2 years. Write it out here. Our payments are in G20 and G21, G20, G21, discounted at the euro interest rate of 4% from C9 in year 1 and year 2. And therefore, the value of the euro bond is 9.33 million euros. If we want to know the value of the swap, it'll be the difference in the values of these two bonds. So the value of the dollar bond minus the value of the euro bond converted to dollars, so 9.33 times 0.90 dollars per euro. And that gives us here G23 and G25 times C10, and gives us the same valuation for the swap of $2.69 million. Either approach, the difference in bond values method or the forward rate agreement method, gives us the same result, which it should. I thank you for watching this video.